All right, here's our first video, first pre-calculus video, right? 1, inverse functions. So let's make sure we know what inverse even means. And I'm sure you've heard the word inverse, but just in case, inverse, we'll write it down. Let's use that color, why not? So inverse is just the opposite. So when we say inverse, we're saying the reverse. See, the reverse or the opposite. And we talk about that with operations, right? So if I say, what's the inverse of addition? So with addition, we know the inverse is subtraction. And the inverse of multiplication, division, right? We understand that. So if I said like 5 plus 2, we know 5 plus 2 is 7. So the inverse operation, use red for that, 7 minus 2 will equal 5. So we just reversed the operation. And with multiplication, if we did 5 times 2, we know 5 times 2 is 10. And the inverse operation would be 10 divided by 2 gives us 5. So we understand that. And we're going to do the same with a function. So let's get a clean page going. So also make sure we know what a function is, right? So when you see functions, and you've seen functions to be in pre-calculus, but when we look at an x box, so an x input box, and then there's a y box, right? What should we say is the output? We know x is the independent variable and y is the dependent variable, and x is the domain and y is the range. Right, so we could see, let's say x was 0 and y was 1, and x was 1 and y was 3, whatever the case may be, we'll just throw this in here. So we know we have a 1-to-1 relationship. There's 1x for 1y. 0 is for 1, 1 is for 3, 2 is for 5, 3 is for 7, 1-to-1. It's a function. If you saw something like this, let's say you saw 0, 0, 1, 2, and 2, 3, and let's say another 2, 4, well, this is not a function. It's not a function because if we look at the x, 1x, 2 has different y's. Can't have that. Now, a y can have multiple x's. So you can see, we'll change the color. If we had xy over here, so we had 0 and 0 and maybe 1, 0, that could happen. Y could have multiple x's, but x can only have one y. So remember that for functions, and I'm sure you remember that. And another thing here is what we want to do with functions, with inverse functions. We'll see this notation for a function. With the inverse function, you're going to see this kind of notation up there with that -1 exponent looking thing. So this would be the inverse right over there. So when we do this, we want to reverse what we've done with. So let's say we had x and y, and we had 1, 2, 3, and 4, and we had a, b, c, and d, for example. Well, when we reverse this with the inverse function, we're going to reverse what x and y are. So now x would be a and b and c and d, and y would be 1, 2, 3, and 4. So we're going to go from here to there. And we'll look at that with some questions. All right, let's clear this out. Let's get a question. Sometimes, by the way, these inverse functions are also called anti-functions. You might hear that. And again, just to go over, we're reversing the function. All right. So what if we had, clear that out, what if I had f of x equals x minus 3 over 5? Well, let's look at certain steps we should do. First step is to make f of x just y. Y equals x minus 3 over 5. So that's step 1. Step 2 is to replace x and y, swap them, swap places. So now it's going to be x equals y minus 3 over 5. Just follow the steps. Right? And now we want to solve for y. Now, to solve for y, we got this 5 that we need to get out of there. We want to clear the fractions. So we're going to multiply 5 on both sides, right? And if we do that, we'll get 5x equals y minus 3. That's step 3. Now, if you're wondering how we got that, again, we're going to clear the fractions, x over 1. So we're going to multiply 5 on that side and 5 on that side, and that will cancel the 5 there. And 1 goes in the 5 times, and 5 times x is 5x. Now, step 4. Let's put that 5x equals y minus 3 up here. We add the 3, do the opposite operation. We're going to have 5x plus 3 equals y. And we're almost done. Now we just have to make, instead of having f of x, we're going to have the inverse notation. Step 5. Go back to that color. So we're going to say f with the negative 1 up there, x equals 5x plus 3. And we're done. We just inversed it. And how do we know we're right? Well, let's look at let's clear this out. I'll give you a few seconds if you want to write it down, or just rewind. And we'll clear it out, and let's put both of those equations back in. Let's have the f of x equals x minus 3 over 5. And over here, we'll change the color. We'll say f, the inverse function, that negative 1 up there, equals 5x plus 3. So if we made an input-output box up here, here's x and here's y. Let's say x was 0 or anything. You put any numbers you want in here. They should come out the same. Let's say x is 3. 3 minus 3 is 0, and 0 over 5 would give it 0. What if we did that over here? What if we reversed it? If it can't reverse, then we did something wrong. So in this case, since x was 3 over here, we want y to be 3. So if x is 0, what do we have? 5 times 0 is 0. We get 3. It did reverse. Let's try it again. What if I had, change the color. If I said 8, well, 8 minus 3 is 5. 5 over 5 gives us 1. What if we reversed it? 5 times 1 is what? 5, and 5 plus 3 is 8. See? We know we did it right if you can reverse the input-output box. So let's try another one. And go back if you need to. All right. What if I had f of x equals x plus 5 over x? And with the condition that x does not equal 0, or otherwise it wouldn't be a function. You can't have 0 in the denominator. So what do you think we should do? Step 1. Just like last time, we're going to say y equals x plus 5 over x. It's the first step we want to do, remember? And the second step, what do you think? Swap the x and y, right? So now we're going to say x equals y plus 5 over y. And what is step 3? What do you think? Well, we want to bring that y on both sides, right? We want to clear the fraction. Multiply y on both sides, and that will give us x, y equals y plus 5. And now we got to get rid of that y over there, right? We don't want two y's. So we're going to minus the y on both sides. This one's a little harder, this problem. So we'll get, step 4, we're going to have xy minus y equals 5. And then what we can do, since we only want one y, is factor. We can factor this. And when we factor that, if we take out a y, we'll get x minus 1 equals 5. Right? And now all we have to do is get the y alone. So we're going to divide x minus 1 on both sides. And we're going to have our answer y equals 5 over x minus 1. Or remember, we're going to do it in inverse function notation. We'll get that. So if you ever see a problem like this, just remember you want only one y, not two y's. That's why we had to do those steps. All right, so I'm going to clear this out in a minute. Rewind if you need to, and let's rewrite the problem and see if we can make an input-output box and it works. Let's see. All right, let's use that yellow. So again, the first one we said that f of x equals x plus 5 over x. We did say that x cannot equal 0. And if we had an input-output box, let's say that x was 1. Well, what would y be? Well, 1 plus 6 is 6, and then 6 over 1 will give us 6. So let's look at when we did the inverse function. We said f, the negative 1 over x, equals 5 over x plus 1. Will we get a reverse input-output box? So we need a 6 there. Well, 6 minus 1 is 5. 5 over 5 gives us 1. So yes, it worked. All right, let's try one more. All right. Let's see if green works. What if I had f of x equals 2x plus 3? Try this on your own. See what you get. Don't forget to check with the input-output box. Pause the tape if you want to. So what'd you do? Did you pause the tape? Maybe not. Doesn't matter, right? So let's say now we did what? We did what first? We made it y equals 2x plus 3. And then what did we do? We swapped, remember? So now we're saying x equals 2y plus 3. And then we're solving for y. Bring that 3 out of there. So now it's x minus 3 equals 2y. Divide the 2 on both sides. And what do we have, right? We can say now that f, the inverse function, equals x minus 3 over 2. And let's check what an input-output box. So let's say for this one, we did x, we did y. And let's say we said x is 0. So when x is 0, y should be 3. When x is 1, what should y be? It should be 5. And 2 should be 7. So we should have the reverse of that. Let's see if it works. What if x is 3? 3 minus 3 is 0. 0 over 2 is 0. Works there. If it was 5, 5 minus 3 is 2. 2 over 2 is 1. Works there. And if what it was 7, 7 minus 3 is 4. 4 divided by 2 is 2. So it works. All right, that's our first video on inverse functions.